Can we get the fourth component? This is how you are going to get the third component, the fourth component. You are going to multiply the second. You are now multiplying the second row with the first column to get the fourth component. To get the fifth, you multiply the second row with the second column to get the fifth. To get the sixth, you multiply the second row with the third column. Do you see the pattern?
Yeah.
That is how you're supposed to do it. Then now tell me, how are we going to get the first component of the third row?
Is 821 multiplied by
which row?
B13.
I mean, which row and which column do we multiply in order to get the components on the third row?
It's row 3, column 3.
Yeah, in order for us to get this one, we multiply row 3 and column 1. To get the next one, it's row 3 and column 2. And then the last one is row 3 and column 3. Is that clear? Can we do an example so that you see how we get to this answer? Okay, it's calling. Hello? Nah. Network yako tena. Oh, abajeni don't number lock at this side. Musigoje. Okay. Yeah. Okay, let's wait for him to join. I want to do examples so that you see how we get to the answers for this. Let's wait for him to come back to the meeting again. Okay, but in the meantime, let me wrap this and we'll pick an example from application of the two matrix. So now we're going to use these two matrix to multiply together. Let me find out if it's in. Bomnya?
Yeah, the numbers no, the numbers. Yeah.
Okay. Yeah, I know. So because though we pick an example, in the multiplication yeah, matrix 3x3. I know multiplication 3x3 is similar to multiplication 2x2. But an issue is the most reachable divide. So you don't need to go to the focus circle. But now let's just pick an example for 3x3 and see what we obtain. So let's say we are given a matrix A given by 2, 0, 1, 3, -2, 6, 0, 2, 0. And we're given another matrix B, which is given by -7, 1, -3, 0, 1, 0, and then 2, 4, 1. So we want to multiply these two matrices, multiplication of matrix A and matrix B. So now, the very first thing we need to do is to check the size of these two matrices. So the size of matrix A is 3 by 3 because we have 3 rows and 3 columns. Same thing with
Columns, yeah.
matrix B. Same thing with matrix B. We have 3 rows and 3 columns. So now, this is a must that they must be the same. The inside size, they must be the same. These 3 must be the same as that 3 for these two matrices to be in a form where we can multiply. Otherwise, if they're different, we can't multiply them together. And the 3 outside and the 3 outside there, they give us a size of these few matrices we're going to produce here after multiplication. So after multiplication, we're going to get a matrix of a size 3 by 3. Reroll them to Shrapanan.
A.
Okay. And then from there, he left the meeting again. He's gonna get the record. Okay, then now the multiplication of A and B, we're going to have 2, 0, 1, and 3, negative 2, 6, and 0, 2, 0. We multiply these together with negative 7, 1, negative 3, 0, 1, 0, 2, 4, 1. Of which, when you multiply them together, you're going to multiply first row and first column in order for you to get the first component. Can you multiply that and tell me what you obtained when you multiply them together? What is multiplication of row 1 with column 1? Can you do that multiplication?
So it's 2 and a 7, 14.
Negative 14.
Yeah, negative 14. And 0 and 0 and 0.
0.
Do I say plus?
Yes, you add all these components.
Then 2 and 1, eh? Which is 2. Ne? Then I go to the second column.
Yeah.
Second column with row 2. Ne?
Yes.
1 and the 3 is 3, ne? 1 and negative 2 is negative, meaning we're gonna have minus 2. Yes. Then 4 and the 6.
Yeah, it's negative 14 plus 2, which gives you negative 12, right?
Where did you get the negative 12?
So is 2 multiplied by negative 7?
No, it's okay. It's 1 and the 3 is 3. Then 1 and the negative 2 is negative. Okay. Then 4 and the 6. So where did you get the negative 7? I'm confused.
Is it we are looking for getting the value of the first component there? So you multiply this together with that.
Yes, that's what I did.
So you multiply 2 and negative 7. What do you get when you multiply those?
It's negative 14.
And then you multiply 0 and 0. is 0. 1 and 2 is 2. Therefore, negative 14 plus 2, it gives you negative 12.
Yeah, okay.
Yeah.
I have to write, okay, negative 12.
Yeah, and then multiply this with that. So it's going to be 2 multiplied.
Then it's second row with column 2.
Mm. So it's going to be 2.
1 and a 3 is a 3.
Yes. So it's 2.
Then 1 and minus 2 is minus 2. Then 4 and the 6 is 24.
Which one?
Then
Which one are you getting now?
now I'm on row 2 with column 2.
No. You are still on row 1.
Okay.
You are on row 1 with column 2 in order for you to get component 2.
So it's row 1 with column 1.
Yes.
Oh, now I must do column 2 with row 1.
Yes.
Next, row 1 comes. Well, then row 1. Okay, it's 2 and 1. 2 and 1 is a 2. 0 and 1 is 0. Then 4 and 1 is okay. Meaning now we have 6.
Yeah.
Then we go to the corner. Okay. Then it's the row one with column 3. Ne?
Yes.
Minus 3 is minus 6. Then 0. Then 1. Minus 5.
Yeah, let me write them for you. So it's 2 multiplied by negative 3 plus.
Hello.
Yes, let me write them for you. You will see how we're getting there.
Hello.
Yeah, I can hear you.
Yeah. So we have minus negative 12, 6 and
So it's 2 multiplied by negative 3, which is negative 6, plus 1, which is negative 5. Then we go to the second one, we multiply this with that, it's going to be.
huh? Yes, negative 5. That's what I got.
Yeah, negative 21 plus 12.
Now you're doing row 2. Okay, now we add row 2 with column 1.
So it's going to be negative 21 plus 12. So negative 21 plus 12 is going to be negative 9.
Okay, it's negative 12.
And then this with that is going to be negative. It's going to be 3.
16.
27.
7 and 3 is 0 and
So negative
okay.
9.
Negative
Negative 3.
negative 2 1 plus 12. Negative 9, eh?
Yeah.
Then we are at column 2. The row 2 with column 2, ne?
Yeah.
It's 3.
So verify if you are all able to get these values
3.
that we have there.
minus
Can you please, Vumya,
Wando.
can you please confirm if you can be able to get these values we have here? So by using the multiplication I've introduced to you, multiplication of 3 by 3.
I'm afraid because I just joined you just now. It was showing me flames the Zoom.
Oh, the network. Okay. No, it's okay. So, but what we are doing now, we are still on multiplication. We haven't done much because we are still covering the multiplication of two matrices.
Okay.
Yes. So let me quickly explain to you how we multiplied the matrix, and then from there you will try to get the matrix that we have there. So this is how we're going to get the components for this new matrix we're supposed to obtain there. So for the first component, you obtain it by multiplying the first row and the first column. So if you multiply first row and first column, you will get -12. So let's multiply that and see if indeed we get -12. So you say 2 times -7, which is -14. 0 multiplied by 0 is 0. And then 1 multiplied by 2 is 2. Therefore, you add them together. So when you add them together, they're going to give you -12, the one we are looking for. So you do the same thing for the second component. You multiply the first row and the second column, of which if you multiply the first row and the first column, you're going to get 6. And for the third component, you multiply first row with the third column, of which you're going to get -5. And then to get the second component there, the components of the second row, you are going to multiply the second row, the first column, to get the first component. And then the second row with the second column to get the middle component. And then the second row with the third row to get the third component on the second row. So it's the same with the other component that we have down there. So it's the third row with the first component to get a 0, and then the third row with the second component to get a 2, and then the third row with the third column to get a 0. Can you quickly confirm if by this multiplication you are able to get this matrix?
How did he get why under 6? It's how much? Is it 27 or?
You mean on this one?
Yeah, on the second one. It's like I got -9, then the other one is how much?
Compare them together and see what we get. So is this multiplied with that? So it's 3 multiplied with 1. We're going to get a 3, eh? And then -2 multiplied with 1 is -2.
Yes.
6 multiplied with 6 multiplied with
is 24.
Is 24 plus 24. So now the answer for this is 25. Is that so?
Yes.
Yes, so it's 24 here, not 27.
You said
25.
You said yeah.
Yes. So quickly confirm all the components there before we go to the critical lesson for today. So this is going to take us more time, where we do the division for 3 by 3 matrix. Are you fine with that matrix we have on the right hand side?
Yeah.
Okay. Vomya, I confirm of it. O matrix una right hand side with this.
Yeah. Ndaba Farabondo.
Okay, then now, and let's go to the critical lesson for today. So here is what is the main thing for today's lesson. What we have covered so far, I was just brushing through what we have covered the last time. So, but now we're going to the critical part of today's lesson, which is about the division of the two matrices. So now, with the division of matrix, we are not allowed to say 2 divided by -7, 0 divided. No, it's not gonna give us what we're looking for. So this is what we're supposed to do. So if we want to divide matrix A and matrix B, we have to say A multiplied by inverse of B, and then that will give you A divided by B. So, but now the problem with this is how do we get the inverse of B? It's what is difficult for us to find. Bomunyai ndono khavara navo inverse ya matrix wa 2 by 2. So matrix wa 2 by 2 ro shumisela method une hoyo method au shumi kha matrix wa 3 by 3. Rerothems.
Yeah, we're together, Mr. Ndo.
Yeah, so I'm going to cover something which is a bit difficult, but you have to bear with me on that one. So the main task here is to get the inverse of B. So this is how we're going to get the inverse of B. So we use a row echelon form. I've told you a bit about a row echelon form, of which we write a matrix B with the dotted lines, but on the other side, we have in the identity matrix. So what is the identity matrix? Identity matrix for 3 by 3 is given by this. So on the diagonals, we have 1, but on the everywhere where we don't have diagonal is zeros like this. So this is what is called the identity matrix. We have ones on the diagonal, but everywhere beside on the diagonal, we have zeros. Are we all together on this?
So it always like that.
Yes, it's the identity matrix. It's always like this. So now, with this kind of matrix, we are working towards on achieving this goal. So instead of having identity on the right-hand side, we are going to produce the identity on the left-hand side. And once you are able to produce the identity on the left-hand side, I can tell you what you're going to have on the other side is going to be the inverse of B. So we will start with this, and then we work with that until we produce the identity on the left-hand side. And then if we are able to produce the identity on the left-hand side, I can guarantee you that what we have on the right-hand side is the inverse. So is this inverse, of which if we want to find A divided by B, we can then multiply the matrix A and the inverse B, and we obtain the A divided by B. Rewrote themselves. Mathomo a zwine ra khou tea u ita a ri thu thoma u ita calculations hafhanoni, mara goal yashu ndi yo achieve hezwi zwine zwa vha hone. So ri ḓovha ro ṋewa B and identity I, and then task yashu ndi yo ri kha left hand side ri vhe na I, and then ra producer I kha right hand side, kha left hand side ri ḓa ro producer zwithu zwine zwa vha inverse matrix B. Rewrote themselves. Okay, let's start. Let's start to do that task just now. It's gonna be very long, but let's see how we get to that task. As I've said, we are starting with B and I, of which B and I, you can write them as the B that you are given there. So it's -7, 1, -3, 0, 1, and 0, 2, 4, and 1. Then here you have the dots, and then on the other side, you now have the identity of 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is what we have at that side. Okay, and then now, how do we produce the identity matrix on this side? We do it step by step. So this is how you're supposed to produce the one on the right hand side. is similar to what we have done a bit before, but on that one, we're looking for the zeros only below the diagonal. So now we are going to produce the zeros below the diagonal and also above the diagonal. Because if we produce zeros below diagonal and above diagonal, we'll only be left with the diagonal, of which on the diagonal we can then divide with that. Let's say we have -7, we can divide with -7, we obtain a 1, and then here we have 1, 1, therefore we'll have produced the identity which we are looking for. So now let's just hands on that task. And we must follow the order. I think the target this order is important. You start by getting this 0 we have here. We start by getting this 0, and then we go to this 0 here, and then we go to that 0 there. You jump the 1, you go to this 0 here, you go to that 0 there, and then you finish with this 0 that we have there. So now, fortunately, on the first 0 that we're supposed to get, we already have it, therefore it's no longer a problem. So we are now left with getting a 0.
Can you please repeat yourself?
Okay, let me repeat again. Our task here is to get identity matrix on the left side of this row echelon method. So now already we have a 0 there, of which is a fortunate part of this problem also.
Yes.
So you're supposed to follow the same order. You start by getting 0 here, and then you get a 0 there, you get a 0 there, you jump this, you get a 0 there, you get a 0 here, and then you finish by the 0 there. So the order is important. You must follow the order. So now let's start. The first 0 we have it already, so we are fortunate. Now, can any one of you tell me how are we going to get this 0 down there? How do you think we can get the 0 here?
By multiplying by 0.
No. we can't multiply by 0. Because if we multiply by 0, it's going to destroy this whole equation.
By 18 minus -2.
You don't add, you only multiply here.
I don't know.
Okay, let me give you a clue of how you go about this. On row 2, row 1, you multiply by 2. On row 3, you multiply by 7. Then you can add them together to give you a 0. So let's quickly do that and check what we get. So it's 2 row 1, which gives you 1. And 7 row 3, which gives you a new row 3. So by doing so, this is what you're going to get. So I'm going to wrap everything that you're.
So we're going back to gas, what?
It's not gas, this one. Is it for gas we're getting zeros down here? So here we're going to get the zeros below and the zeros above.
Mr. Ndo,
Nah.
I think what this guy is trying to say is trying to ask if you must use the same method as for the Gaussian elimination in order to find the zeros.
Yes, we are following the same procedure.
Yeah, that's what I was saying. Thank you.
Yeah, we are following the same procedure. Okay. So now let's do that and see what we obtained. On this one, we multiply by 2, and then on the other one, we multiply by 7. So on the first one, we're going to have -14, and then 2, -6, and then here we're going to have 2, and then 0, 0. So the second one, we just repeat this as it is. And then you will have 1, 0, 1. we have 0, 1, 0. So now the last one.
So the second row, we're not gonna touch it because like already we have zeros.
Yeah.
Okay.
So then the last one, we are going to multiply it by 7 and we obtain 4. Why is 7 multiplied by 4? We're going to get, is it 24?
28.
It's 28, yes. And then here we have 7, and there we have 0, 0, and then 7. Okay, then after having this, we can then add row 1 with the row 3 in order for us to get row 3. So let's add and see what we get. So we want to have negative 14, 2, negative 6, and then 2, 0, 0, and then the